Okay, good morning and welcome to the actually last lecture in this course. We will have a peer instruction this afternoon, but this is the last lecture, and this lecture today is more or less okay. So now we got the tools. What's in the future? What could we do with the tools we have? The techniques I will talk about today is more or less just for inspiration. I mean, there are parts of the APIs that I will talk about today that you, of course, if you like, you can implement in the third assignment, but that's totally up to you. So you have, since last week or even the week before that, you had all you needed for doing the last assignment. Just a quick note and reminder about the rest of the course. So on Friday we have re-exams for the second assignment. It will be totally over Slack. Next week we have examination on Wednesday. The times will probably be published this Friday, so you can book a time. That will also be over Slack. And it might even be so that we will not be able to fit everybody on that Wednesday. In that case, there will be an opportunity the week after as well. We will have to see. The problem is all courses are going to be examined the same week. That is next week. And we have a lot of courses. We are involved in like 3 courses, and every course have an oral hearing, and the oral hearing takes a lot of time. And I didn't want to place your oral hearing this Monday, because then you had in practice only 8 weeks to complete this course. So Wednesday was the last day we could have it, and maybe we will have to even add sometimes the week after. We'll see. We will make it work in some way that suits everybody. After that, there will be a re-exam once again, like 2 weeks after next week. So in 3 weeks or something like that, there will be a re-exam. And that re-exam is for both the second and the third assignment. And that is the last one this semester. Then we might have some kind of re-exam in the spring or summer, and then the next time the course is given again. So that's the examinations. Some questions about what will be the theoretical part to this third assignment. Well, it's more or less the whole course, even though on the second assignment we covered the basics. So we will probably not, we will just, I mean, you will need those basics to be able to do the assignment anyways. And I think we will focus quite a lot on your application in that part, much more than we did in the second one, just because that application is more complex. There are more things to discuss. So we will probably have your application as the foundation for having a discussion, and while we have that discussion, we will ask you some theoretical questions, and you could answer them by reason about your code or just answer them right up. There are some of you are going to take the next course, the 523. And we've got the lists for those students, and you haven't been accepted to the course because you have a conditional statement that says that you need to finish this course before that course. However, the rules will be like, on Friday we will have a look, and those of you who have done this second assignment, then it's fine to read the next course, so you don't need to be finished with the third one. But we will do this after, I hope, at least. It's not my course, but that's the plan anyway. Yeah. Let's see, so everything is working. I need to have Slack as well if I get questions. Any questions here regarding the continuation of the course?
How long is
It's 30 minutes, yep. Or in practice 25, yep, give or take. Okay, doke. And remember, peer instruction this afternoon, and the peer instruction will have questions covering more or less, as last time, examples of questions that might turn up on the exam. So, APIs in the future. The fun stuff. So, we will talk a lot, or just briefly go through a lot of APIs that are upcoming in the browsers. Some of them are quite stable, like web workers and Canvas. Some of them are really not that stable, like using web components, WebAssembly, for instance. But you've all heard the term HTML5. And when HTML5 was presented, this was kind of, yeah, this is the future. This is like, you can do everything in the browser. And sometimes you can hear like, yeah, in HTML5 you can do this, and in HTML5 you can do this and that. However, HTML5 is quite limited in the specs. And the browsers are built upon, okay, the HTML5 is the foundation, and then APIs are added to the browser, which has no connection to HTML5, but they are often, the umbrella term, so to speak, has been HTML5. So even if we say that, yeah, this API was introduced in HTML5, that might not be the case. It could just be that this API was added at around the same time as HTML5 came. And we can start looking at some of those APIs that, and web workers is one of those APIs. So last time, or the time before, we discussed service workers. I think that was the last time. Service workers, and service workers, as you saw, had its own queue. So we had a main queue in the browser executing the JavaScript, and then we have the service worker going in parallel. And you saw that this had the global the global worker scope as the global scope, and that indicated that there are other worker threads as well, and web workers is one of those. So what this is, I mean, if you can more or less see this as starting a new thread. So if you want to do something that is calculation heavy, you should not do that in the main thread, and you know why, because that will lock up the thread, and the UI and everything will lock. However, using something like web workers, you can delegate this task to a web worker, and the web worker will do this in parallel with the other code executing. And whenever it's finished, it could send a message back to the main queue saying, okay, I'm finished, I've got a result for you, and you can present the result. So as soon as you come into a problem where you feel like, okay, so this part of the code, in my case, it's really fast. However, in some cases, this might be really, really slow. Then you have a couple of options. You could just go with it, hope for the best, and in some special cases, this code will lock up the main thread, and you're okay with that. That's the simple solution. The second solution is using timers, so that you have some kind of calculation loop, and every 1,000 or 10,000 iterations, you just set a timeout, and you more or less pause this execution, and you come back and continue the calculation in a later time. I mean, that is not a problem, because then you will free up the queue, and you will kind of just postpone the next calculation, and everything will, the rendering will go through, and then you will do another 1,000 calculations, set a timeout for 0, and continue. And then you kind of like let someone come in occasionally and do other stuff in the browser. That's okay, you can do that, it's often done. the best thing today, I should say, is using web workers instead. So instead of doing that calculation in the main thread, you just delegate it to another thread. It's quite simple to work with. So first of all, you need to create a new worker. That should actually say new window.worker according to standard.js. So I forgot the window prefix. So let a worker equals new window worker, and then you point at a file. So the code being executed must be originated from a separate file. So you cannot like inject the code or something like that. You need the code in a separate file. This is run in a separate part in the browser or in a separate environment in the browser. In this case, if you're doing the chat application and using sockets, you know the drill. So we listen for messages from this worker. What that does is when this worker sends a message to us, we will fetch that message and we could do something. It could be a calculation that will be quite heavy to do. In this case, we have some kind of prime number calculation. So if we look in the worker, this might not be the best example, but hey. So we have some kind of, okay, so I just copied this example. This is a named while loop. You can do things like that you name this while loop to something and we could tell this one to continue instead of continuing the for loop because the statement is in the for loop. However, it doesn't matter. This is just calculating prime numbers. And I mean, this one will go on forever. If we did this in the main thread, we will lock the thread and nothing will happen after that. Well, the browser will crash or present a message saying this script is just clogging the browser. Should I stop the script? But in this case, this is run in a different thread in the browser. Whenever it finds a new prime number, it will post a message and it will send that prime number as a message. So every time this one finds a new prime number, we will be able to get a message and we could fetch the message by e.data and then we just add it to the page. So this one will just like add prime numbers to the page as we find them without clogging up the main thread. Yeah, that is basically it. So what we've done is made our code asynchronous, more or less. Of course, you could write some wrapper to have promises, and so this one, when you get an event listener, you could resolve a promise or something like that. You could like wrap it however you like. But it's quite a simple model. But this is what you need to do if you have code that will take time to execute, more or less. Okay, yeah. So in the third assignment, well, feel free to try it out if you like. I'm not really sure where it will like fit if you don't do a application that is heavy, but well, you could try it out if you like. Going on, HTML canvas. So canvas is the ability to like do drawings and things on the web page. So a canvas is just a blank area on an HTML page. It's the canvas element, looks like that in HTML. So you add a canvas element, you can specify how big this area should be on the page, and then you can do things like drawings. You could add photos and modify the photos and use filters. So if you were to do like an Instagram application, for instance, you would probably add a canvas, you would add a picture that the user takes on that canvas, and then you would apply filters or write your own filters using JavaScript to calculate how that image should be presented. You can do animations. You can use this to do real-time games. So the games I talked about last week, you know, the Agar and Slither and whatever they are called, they use canvas elements to plot. Yeah.
I actually implemented a canvas element in one of my applications, but like once you zoom in, it's kind of pixelated. Is there any way to do it like as a vector graphic?
Yeah. So canvas is pixel-based. We have the SVG as well, scalable vector graphics. So SVG will work with, that is vector graphics all through. So you can zoom in how long you will, and it will look good.
SVG is something that you load from an external source, right?
You can generate SVG from JavaScript if you like. So you can use it from JavaScript. Often SVG is like a file that is it's only XML if you look at it more or less, and it's coordinates, and you load that file, and the browser will present the image. So it's perfect for like logo types, for instance, because it will scale. So even if the logo type is small or big, it will always look the same, and the file size is pretty small. So I mean, if you were to do like a simple drawing program, for instance, where you want to use like vector graphics and be able to zoom and zoom out, then SVG is probably the way to go. If you were to do more like a MS Paint application, this is probably the way to go, because that is also pixel graphics. So yeah, Illustrator versus Photoshop, if you like. Yeah. And this is Photoshop. So, for instance, if we look at this one, it's perfect to use if you want to plot like diagrams and stuff. This is some kind of game of life simulation, and it's plotted like this. But if I were to zoom in, as you said, it will probably not scale that well. Yeah, you will see that this is pixels. It's pixel graphic. It's not vector graphic. If this were vector graphic, it will be a smoother experience. This is, I mean, I think I could have can I use as a resource to this lecture, because hello. Can I use has been so slow the last month. Oh, well, without looking at can I use, I could say that this, come on. That this canvas element is the support is good. So you're probably down to like IE6 or something like that if you don't have support for canvas. Then of course it might be that the whole specification isn't supported in every browser, but basic support should be in every browser for canvas. Something that is gaining popularity and have done the last year or so is VR. And there is a API being developed called Web VR API. And this is getting broadly adopted by the browser vendors. I think it started out, if it wasn't like, could have been like an employee on Google or something that started it. But I think it's getting acceptance as a V3C standard for doing VR applications in the browser. I haven't worked with it, so I can't say anything about it, really. But I mean, it's a standard. If you apply the standard, browsers that are in VR mode should be able to pick up like the images. You will be able to do some kind of settings and things like that. Okay, let's see. Web VR. Oh, it's not here. Oh, well, okay. So the support is actually getting there. Look at that, Edge and Firefox, and it's in Google as well. If you, but you need to add a flag to activate it. Looks like. So, but Safari, well, no, not supported. And as I said last time, you will see this pattern over and over again, that Safari unfortunately is not supporting the those APIs. Canvas, yeah, so the support for Canvas is, as I said, really, really good. You can use that right off the box. So where we are, there is actually an old API in the browser that is kind of gaining popularity again when WebVR is gaining ground, and that is the Gamepad API. So this is an older API that is used when you connect the gamepad to your computer, and so you can use the gamepad for playing games in the browser, for instance. And you could just listen for an event on the window object called gamepad connected. And when this event occurs, you know that the user connected a gamepad, and you can like get information about the gamepad. How many buttons? Does it have like analog support for steering and things like that? This is getting updated to support VR controls as well. And that is probably a game changer when it comes to using VR on the web. You will need to have some kind of controls to be able to do things. So it's pretty up to date. Gamepad API, I haven't checked those. Gamepad, well, not Internet Explorer, but more or less everything else. Oh, this one I like. So a couple of years ago, it's like 4 now, I was on a conference in San Francisco, and I listened to the creator of something called the physical web. That was quite new back then. We have a problem in like trying to connect to things in our surrounding. We could use like QR codes to pair. We could use other techniques to like try to communicate, but those techniques are often they are using quite a lot of power, or they are for the user intrusive, or in other ways hard to grasp. So what physical web beacons is quite a simple concept. I might have one as well. Let's see. No, it's at home. So what a physical web beacon is, it's just a low energy Bluetooth beacon sending out a web address, just a URL every like 5th second or something like that. And then it's up to the environment to pick those signals up and do something with them. So the concept is super simple. You could like just take an Arduino or whatever, Raspberry Pi or whatever, and just add a simple library to Node or whatever, and just make this a beacon. It's really, really simple. So, for instance, if you're going to catch the bus, and you get near the bus stop, and you pick up your phone, and the bus stop is sending a beacon signal. And I mean, this beacons, they are really power efficient. So with a simple battery, a beacon can be alive for like 2 years or 3 years or something like that. So it's not consuming at all. But when you get close to the bus station, you can pick up your phone and you can look at nearby beacons. And then you just click, oh, the bus stop, and then you get a timetable when the next bus is coming to this stop, for instance. I mean, it's only sending a URL, but when you click the URL, you will get more information. So this is basically solving the problem of bootstrapping, how to get the user to find our applications and use our applications. You could go buy a window on a store that you like, and you pick up your phone, and then you could just select that beacon, and you get some good offers or something like that. Instead of, I mean, the common thing today is using QR codes, right? So, okay, I need to pick up my phone, I need to use the camera, and I need to go close, and it's quite easy to do phishing with those as well, just adding your own QR tag on top of the original one, and you have done some kind of, you can overtake that signal. It's a little bit trickier using beacons like this. So this is an example. I will play it for you. I'm not sure if we have sound. I will speak. Yeah, so this is a parking meter. When you get close to the parking meter, you just open control center. This is the old iOS. You open the control center, you get a parking meter. And what it does is just opening an URL for this parking meter. And you communicate over the web to the parking meter. And then you could just set a time and do whatever you like with this one. So it's really, really simple way of connecting to devices. It's an open standard. It was developed by Scott Jensen. You can find out more on this page. There are many different use cases. This is just one. I mean, it could be like what this beacon is doing some kind of handshake, and you can get the application by Bluetooth from the parking meter directly if you like. So that is also a use case. And there are several use cases. I'm not sure about the support yet. Not sure it's... No, it's not there yet. I think it's from last year. It's native in Android Nougat, something like that. So by being so, you could, if you have an Android phone and you get near a beacon, you will get like a little symbol in the taskbar saying there are beacons nearby. On iPhone, you need to download an app, and I'm not sure if I have it installed. No. But you download an app and you will get the same, more or less, functionality. But it's built into Android, so will probably work better on, in that environment. So this takes care of the bootstrapping problem to be able to communicate. I mean, this in your house, this could be like a light bulb that you need to control or whatever. The next thing, and when this starts getting interesting, is web Bluetooth. So connecting to Bluetooth applications or Bluetooth like keyboards or Bluetooth devices on the web before wasn't that easy, because that was the operating system that made the pairing with the Bluetooth device. Now we could do it using the browser without involving the OS. Well, the OS is involved in the background, of course, but as a developer, you could just, if you develop an application for a smartphone, you can use the web Bluetooth API to pair with Bluetooth devices without the user needing to go into the settings of the phone, for instance. This is quite new. I think this was released like last year. I think we have it. Whoa. Web. Yeah, web Bluetooth. Support in Chrome is pretty good. In Opera as well. Of course, not in Safari and not... Okay, so it's under consideration in Edge, but not in Safari, unfortunately. I mean, this together with the physical web will make it so that you could actually, that parking meter that you saw, it could be paired directly to that application using Bluetooth, if you like, without involving the phone's operating system. So yeah, I think this, I mean, this came out like last fall, something like that, so it's only a year old, but could be fun to try out if you're into Bluetooth devices, home automation and things like that, then this is interesting. When you're programming this third assignment, you are probably starting wondering that, okay, so my code is beginning to look like spaghetti. because I have all those, I mean, applications and everything is loaded when I start my application. And how should I divide it? Well, you could divide it into modules, and you probably are in that assignment. So you have like a module for the memory, a module for the chat, a module for, I don't know, Windows, a module for the desktop, something like that. And by module, I mean you have them in separate files and you do a require and the export on, for instance, the memory game. Well, that is one way of like dividing your components. However, there is a new concept, and that is called web components. And this is like how we should start to think about applications from now on using the web. However, web components consists of more or less 4 concepts. It's custom elements, HTML imports, templates, and shadow DOM. If we were to break it down, well, templates, you've used templates probably by now. I talked about them in the DOM lecture. Templates are pretty well supported in the browsers, so that's not a problem. However, the shadow DOM, HTML imports, and custom elements are not. You will probably get this where this stack will work in guess what? Chrome, yeah. So you will get it to work in Chrome. You will not get this to work in Safari, for instance. Well, good guy Google has made a polyfill for this so that if you use the polyfill, it will work in the other browsers as well. I will not talk about the polyfill. I will show what it's called, but we will more look at the native way of doing things. Hopefully that is the future anyways. Okay, custom elements. I mean, you have learned a lot of HTML elements. You know what head is, you know A, image, P, div, and so on and so forth. What if we could do our own components or elements? So what if we need a flag on our page indicating the language of the page. And if we click the language, we will get a small menu and we could change to another language and the page will show another language. So that flag component, I mean, that is something that you will probably use on many sites that you do. Why not make that flag into would be really neat if that flag was just an HTML tag. So by writing like flag icon, you will get that functionality on your page. Well, if you were to do it now, with what you know now, you will probably include some kind of JavaScript, and you will have like a div call with an ID flag, and you will fetch that div, and you will add the icons, and you will add some dynamic stuff with click handlers and things like that. Fine, will work, and you could copy that code to the next project and so on. However, with custom elements, we can create our own HTML elements. And this is the first key to doing what is called web components. Let's see if I have some examples. I haven't done my own examples. I was actually, if you've looked at the autocomplete demo, where I have the football teams and I do the autocomplete, yesterday I had an hour where I could just code. That is not usual anymore, but I had a whole hour. So I tried to like web component that application. I didn't get all the way, but I will probably in the future make a demo with that application. So we will have to look in the demos in the documentation. So this is kind of like the example I talked about. No, I can't. Can you see? I will remove myself like that. So we want this to happen. So we have a flag icon element, and we set country to ML, and that is it. This should then present the flag and all the stuff. So this is pretty simple to get started with. First of all, in this case, we need to inherit from a class or a type called HTML element that is built into the browser. It will actually be, if you were to follow this, the standard JS, you need to write window.html element. It's a part of the window object. In this case, it's pretty neat to use the class syntax, actually, because inheritance using the prototype pattern it's doable, but it's simpler to do it in the class syntax. But you can do it wherever you like. I think there is an example on this page how to do it in using prototype functions as well. We create a constructor. The constructor is calling its superclass, and we just add a attribute country code to be able to track which country is active right now. Then there are some methods that are overridden, like observed attributes. We override that one, and that should return the attributes that we will use on this element. So in this case, it's only the country element. And this will make it so that whenever we change the content of this attribute, the browser will observe that and tell us that, okay, the flag has changed. It might not be our code that changes that flag. It could be code from another component that changes that, but we will get a message when it does. And we get that message by overriding this function, attribute changed callback. So you override that one, and the name will be, in this case, country, what attribute is being changed, the old value and the new value. And then we could write the code for what should happen when that attribute changes. We have some rendering down here, and the rendering is just up to you. You could use like just load an image and place it inside of the tag, or whatever you like. We have a getter and a setter for the country as well. So we could just, we could just call this the object of the flag icon instance, or the instance of the flag icon class directly, and just setting the country, or we could set the country by just manipulating the DOM if we like. So it will, in this case, it will result in the same thing happening. And so this is pretty much what you need to do to set it up and the functionality. But when it comes to actually writing the code using that one, you only need to do this. You do a window.customelements.define, and you name it to something. What should the HTML element be named? And then what class is being used for this element. So when you've done this work, to use it, it's just doing custom elements.define. However, as I noticed yesterday, you need that, what's it called? Dash? Yeah. You need a dash to separate two words when you do this. You cannot name this flag icon without the dash. And that is due to naming conventions. I guess it's because then otherwise you will be able to name it span or div and override the built-in elements. So you need to have a dash. That is actually the rule. Something dash something. Dash something if you like. You need one dash at least. So flag icon or whatever, my flag or something like that.
I have a question.
Yep.
I tried that, but I read about it on the internet. I can't make it run call the constructor. It always doesn't call the constructor.
The constructor should be called when
there is another method that builds up, I think.
Connected callback. Yeah.
I use that instead of constructor, so it doesn't call constructor.
Let's see. So connected callback, that one will be run when the browser has like connected, because what will happen is the HTML will render the page and it will find your flag icon, but it will have no idea what this is. And then it will render the DOM, and it will start your scripts, and then it will, when you do the define down here, it should do this connected callback. I think that, I'm not sure when this constructor is being executed. It should be by the browser, because we are sending a reference to the class, and the browser will probably instantiate this class and connecting it to your instance of flag icon, and then the constructor should be called, and after that the connected callback should be called. It worked for me. Yeah, because I set a default. I remember because I set a default text on my object, and the default text was actually added, so it should work. I haven't done much. You have probably done as much as I have, because this was like how much I was able to get working yesterday. But it worked for me, and it should work in Chrome at least, if you try it. So that's the first piece of the puzzle, being able to create your own HTML elements. Next piece of the puzzle, using HTML imports. So how to import those components into your browser. You could add everything up in one single page, or you can use HTML imports to import fragments of components. So you could create, let's see, is it this one? In this case, let's make it bigger. You tell the browser that we have a component. It's placed in component.html. Then in that component.html, you will not need a head, a body, whatever. You just place the HTML code that is needed for your component. It could be template if you need a template, or it could be just the code that should be inside. Oh well, you will probably place it in a template because you will import it into your when you create your element. Inside of this component, you could add CSS files, you could add JavaScript styles, or JavaScript that you need for this component to work. I haven't tried it yet. I will. But this kind of handles the problem of starting to separating the components. You can separate the component and just load. So what you will basically do on your HTML page is that you will link your component.html, and then you could start to use the tag that you imported. So you import and you use the element. It's not needed to do a web component, but it's one of the parts that is pretty neat to have. Third one, you know this one, as I said, templates. You've used templates. You can add a template inside of the component, and then you can clone that template when you start rendering your parts of your page. I will not dwell upon that. Next thing. So if you look at many of the modern elements in HTML, like the video tag, for instance, we could take the video tag, for instance. So you add a video element to the page. But when you look, it's not just an element, right? Because it's a lot of components. Because you have a play button, a pause button, you have settings. You have a lot of things, actually, by just adding the video element. But if you look in the source code, you will not find the play button. You will not find the pause button. You will only find the video element. However, if you activate something in your browser called show shadow DOM, I think it's under advanced settings, you will notice that the DOM that you see in the inspector is actually not all of the DOM. It's only the DOM being presented to the user. Behind that DOM, there is something called a shadow DOM. And the shadow DOM is one layer more of HTML components. So if you activate the shadow DOM and you inspect the video element, you could actually expand the video element. And then you will find that there are a lot of HTML elements and even style sheets and stuff embedded inside of this video element. And that is called a shadow DOM. So each element in HTML can have a shadow DOM, and that shadow DOM is only accessible inside of this component or this element. So for instance, I think I have an example. So for instance, say that we add a template to our component, and we add this template as a shadow DOM. In the shadow DOM, we add style p color orange and p hello component. If we were to add style p color orange to our page, what would happen on the page? Well, all p elements will be orange, right? However, if we add this as a shadow DOM inside of a component, this style sheet will only be, it will have the scope of the shadow DOM. So doing this will only change that component's rendering. And this is quite nice, because the problem with CSS is that it's hard when you're, okay, so I'm going to only add CSS for my memory game. And then you always need to prefix everything with an ID of the memory game or a class memory game, and then you could like work with this. And if you forget, you will like start changing things outside of your scope. By packaging this in a shadow DOM, you get around that problem. You can only focus on your component. So inside of my web component, or the flag, like the flag that it was the last time, when running the constructor in this case, we use this attach shadow. So attach shadow is a method on the HTML element. So we could do this dot attach shadow, and we could say that, okay, this shadow DOM should be open so that we can edit the shadow DOM. This will create a shadow DOM on our web component. So now we have a shadow DOM. After that, I just query this template, just as you do with regular templates. And I clone the template. That is the same code that you've used before when you clone templates. And then instead of adding it to the DOM, I add it to the shadow root. So I add it to the shadow DOM instead of the regular DOM. So I append the child in this instance, and I add it to the shadow DOM. And now this component has a style and a p. It's not visible for the user. If we were to look, we will only find, in this case, this code, my web component. But if you were to open it in Chrome and you have enabled the flag that you will be able to inspect the shadow DOM, you will actually see that you could like plus this one, and the web component will expand, and inside a web component you have this code. So that's a pretty neat way of like packaging packaging code into components. Support. Well, first of all, it's a working draft. So this is not a set standard. It's subject to changes. However, Chrome is getting there. Firefox is getting there. MS is thinking about it. WebKit is supported. So it's supported in WebKit, but I guess Safari hasn't included that branch of WebKit then. It's not supported anyways in Safari. Surprise, surprise. I think you can start to seeing possibilities of creating components for the web. I mean, this is kind of opening up for a market for developers to actually create components that other developers can use in a more standardized way. It's pretty nice, I think. So combining the custom elements with the shadow DOM, being able to customize those custom elements using templates instead of generating everything with JavaScript, and then last of all importing it using the HTML import. Then we have a pretty good way of working with components in the browser. Of course, if you're writing like React or Angular applications using that framework, they will have some kind of it's a framework for making components, so they have their way of doing this. But this is the native way that we could start using if we like. Let's see. I will actually go on. I have like 15 minutes or so left. So if you were to use this today, in every browser you could use Polymer, and Polymer is Google's polyfill for web components. I guess the support is, I'm not sure if they have a support page. Well, somewhere. Browser support overview. Actually says part, yeah. This one says that Safari is partially supporting Shadow DOM actually. It's not the same as Can I Use It? Well, however, if you use it, you should be able to fill those gaps with this polyfill, if you like. Called Polymer, it's, I guess, kind of popular. So if you like, you can check it out. But so if you were to do this in practice, you would probably need this one. But for just trying it out in Chrome, you do not need Polymer. Next API that is interesting. So when you communicate using the chat, you need to go through a central server, and that is our server. So WebSocket is a connection from the client to a server, and then you can send data. To be able to chat to another client, you need to go through our server so that we have a connection to both of you and you can communicate. Peer-to-peer is quite popular way of communicating as well, and WebRTC is actually bringing peer-to-peer to the web. Web real-time communication, I guess it's the correct term. This is the API, or if you talk to a developer and okay, so we need video, okay, so we will probably use WebRTC then. This is the term you will probably use when talking about this. However, WebRTC is broken into 4 different parts. We have the media stream API, and this is the one that is most commonly used, I guess. This is for being able to stream media peer-to-peer without going through a server. So you could use it to if you want to do a Skype clone, for instance, you will use WebRTC, and you will connect directly to another client and share the cam and microphone and so on. Should be quite starting to get stable. It's so the support is good. Could probably use this today if you like. Media recorder, you could probably guess what that does. Records the stream. So if you want to do I'm pretty amazed that no one's done this, but I mean, you could do a simple vlogging tool just using those API, so that you don't need a software. You just go to a platform and you start the cam and you record a vlog and publish it somewhere. It's pretty simple using those APIs. I've not seen that in a great extent, which it's strange because, oh well, you can use YouTube, maybe that is probably it, but I haven't seen any other products. Works You will probably get, depending on the browser, you will get different file formats. I think it's OGG when you try it in Firefox at least. RTC peer connection. This is for sending, oh, I might mix those up. We have the RTC data channel. I think the data channel is for streaming data. So if you were to write a real-time game, for instance, you will probably set up a RTC data channel between the clients, and you will stream the data between those clients. Of course, that will be a lot quicker than going through a third-party server all the time that has to just forward the messages. It will probably be faster, I should say. And the RTC peer connection. I'm not sure if this might be, the data channel might be binary data, and the peer connection might be string data. I don't remember, but you can look it up. However, the important part to note is that WebRTC is for peer-to-peer connections, and you can do pretty much using this API. WebGL. So, have you taken some like computer graphics course like that? I mean, if you do, you will see that like using C++ and programming things on the graphics card is probably still a thing to be able to get performance. So if we were to just like try to use the canvas to make a game, the performance will not be that great because it will just use the regular CPU of the computer, and it will be seen so. However, WebGL is using 3D acceleration on the graphic card. So using WebGL, you could actually start making real 3D applications and 3D games, and actually start like pushing the limits of what you can do in a browser. I think the Unreal Engine. Do you remember what number the Unreal Engine is on now? 4. I think it might be Unreal Engine 3 that was ported and used WebGL. So games written in Unreal Engine 3 you were able to port them to the web. Quite simple. I'm not sure they've done it with the latest version though. This is just an example of what you could do. It's maybe not the most beautiful example, but using some kind of so this is real-time graphics. They've got the latest shooter, but still waiting on that. I think you actually need to like possibly use I mean, you could always. Today we're using game consoles to play games. If we were to have like the same performance in the APIs on the web, this would be pretty neat. We could probably start seeing more like AAA games coming closer. I'm not sure with that yet. It'll take some time, but I mean, we have the gamepad APIs. We have this one. As we will see, we'll have something called WebAssembly as well. So we could really heavy calculations in the browser. Well, who knows? Maybe in the future we'll see something like this. Back off. WebAssembly, as I said, this is instead of writing JavaScript. JavaScript is good for many things, but it's not good for heavy calculations and solving mathematical problems and things like that. In that case, you will probably need WebAssembly. So you could more or less reach the hardware in the same way as you can with like C++ and C. I haven't tried it. I'm not into hardware anymore, not programming hardware anyway. But you could have a look. Thought there might be an example of something. Oh, this is just proposals for the spec. Okay. But if you find yourself in a spot that you need to do really precise and computational calculations, and you would like to use them you do them in the browser, then this could be something to look up. Normally, you'll probably set up a server doing the calculations, and you will only post messages back to the client. But there might be cases in the future where you want to do this. I mean, looking at my kid is in 4th grade. He's getting his first computer from school next week, and it's a Chromebook. And if you look at the schools more or less all over Sweden, some of the students are getting iPads, but the majority is getting Chromebooks. And what is Chromebook? Well, that is basically just the browser. So everything running in the Chromebook, that's Chrome, and you run web applications. And we have in Sweden, at least, and I think it's the same more or less around the world, we have youngsters growing up using their Chromebooks as their working tool and getting used to working with web applications in the same way that many of us grew up with using like Windows for applications. So, I mean, what will happen in 10 or 15 years when they buy their first computer for their own money? Might be a Chromebook or something similar. And by then, we will probably have a lot of applications that are living up to the standard of desktop applications. I mean, if you talk to a professional writer, you will not be able to lure him or her into using Google Docs, because they will probably use many of the features that are embedded in Microsoft Word, for instance. But in 10 or 15 years, who knows? We might see that the web is so easy to develop for, and it's so easy to find developers that it will grow even more than it has today. At least that is I think that the web, okay, so Android or that is always the question. Should I use Android or should I use iOS? Should I use Mac or should I use PC? And my answer would have to be you should use the web. It doesn't matter if it's Android or iPhone or whatever, because the web is the platform. But I'm kind of biased since I'm having a program that is just for web developing. But still, I think the web will conquer. I said that 10 years ago also. However, what happened was that the App Store came. so that was postponed. If that revolution hadn't happened, I think the web had conquered already. But since the app stores and the native apps came, that was kind of a setback. However, now we see that more and more apps are being written in web applications instead, as web applications. Well, we will have to see. Please tell me I was right or wrong in like 20 years. Well, we have more APIs. Okay, so we have this is kind of a hot topic right now, the payment request API. So Apple Pay is scheduled to be released in next week, something like that. At least to the rumors in Sweden, Apple Pay in Sweden, I should say. It's, and the Samsung Pay has already been released. Payment on the web is a hazard. I mean, we still use this credit card like since the 50s. It was invented in the 50s with the Diners Club cards. So we still use those like numbers with a number on the back, and that's it. And we give it all to the web page, and we just trust that they don't do another payment with. I mean, it's absurd. If you were to, I mean, if you were to develop something and you would come up with the idea of just giving that information, that is so stupid. So we need a way of doing good payments on the web as well. This is being standardized using the payment request API. The support, oh, guess what? Good guy Google. The payment request API, Edge is supporting it, Chrome is supporting it, Opera as well. Safari isn't considering it. However, Google has made a Google are providing a payment request wrapper for the Apple Pay.js API. So Apple actually made their own API, which only Safari supports, of course. But Google made a wrapper for that one so that you could use the standardized payment request API even on Safari, if you like. Yeah, for me, this looks like someone is afraid. I mean, that is the only reason I can see why you would like to do something like this. That you are afraid of losing your position, and you try to like fence yourself. And this is exactly what Microsoft did in Internet Explorer, more or less. And it's happening in Safari right now. But using, I haven't tried this API, but I imagine it will be quite a smooth process when you are hooked up to this support. So if you have a Google account or Samsung Pay or whatever, that payment API will hook into that one, so you could just pay on web pages using that service that you are using, be it Apple Pay, Samsung Pay, Google Pay, or whatever. But I haven't tried it. No. Okay, so there are many more. Geolocation API, this is an API that has been working for quite some time, and you have all used it probably. That's the way you can position the user, more or less. So if you want to know where the user is, you can request using this simple API, you will get the position of the user. The user had to approve it. You have done so because the application will tell you, like, okay, this site would like to know your position, and you click yes or no. So as a developer, you need to handle both situations, if the user says no or yes. The battery status, this one could be more and more interesting since the battery life of our phones are not that good. So if you are writing a game, for instance, and the user's battery is getting low, you could like start to change the frame rate or change things that will make it so that you're not draining the battery. You could like see if the battery is 1%, maybe we should do an autosave, for instance. You can use the vibration API. Surprised this was quite misused when it was first released, so I think they had to change it. But I think you can do some stuff with the vibration function in the phone right now. The clipboard, being able to copy and paste things, and you can access the clipboard. Ambient light, you know, on phones and even on computers, you have this ambient light sensor that will show you information about the light in the room. So you can have a night mode and you can have a day mode, for instance. This one works. I tried it in Firefox. I even demoed it. I don't have the demo here right now, but just a simple web page, and when you turn the light off, ghosts will come into the picture. So it's quite an easy. You will just get a number of how illuminated the room is, or how illuminated the sensor is. Device orientation, is it portrait, portrait landscape, or how is the phone, and gyros and things like that. You can access them as well if you like. So just 5 years ago, this was more or less a dream to have those possibilities. But now we're starting to get in there because the phones are getting so popular. And it's not only the native code that is getting this information. We are getting this information through APIs as well right now. However, of course, if you want to do the cutting edge things with the phones, for instance, using the iPhone and the new AR kit, being able to position things really exactly in the environment, you don't have an API for that yet. But of course, as soon as that was released, someone is probably working on a draft for getting those APIs available in the web as well. Might take a couple of years. In the future, it might be so that those APIs will be developed the same time as the native APIs. But right now, we have some kind of lag for this. Okay, questions so far? Yeah.
Why are you an iOS user?
Why I'm, yeah, that's a good question. Why am I an iOS user? Yeah, I shouldn't be, right? I think I've tried Android, but I never liked it. It's like, you know, you need to break a habit. That is probably the problem. Then I love the phone on the iPhone Plus. So there are probably good phones on some of the Androids as well. No, I ask myself that same question every time I have this course, because why are they so stupid? No, I can't give you a good answer actually. just by habit, I guess. Yeah. It's often, I mean, if you look at developers, I think developers tend to use Android in a larger extent than the rest of the population, at least in Sweden, I guess. I mean, in Sweden, iPhone has like 70% or something like that, 60 or 70%. So iPhone, worldwide, I think it's like 30 or 40, something like that. So Sweden has always been like Apple country. So. Okay, thank you. I will see you in 1.5 hours, more or less, 1:15, and we will have the last peer instruction. Will not probably be as long as last time, but I have a couple of questions at least. Okay, thank you.